And year 10, we are back again. Let's just do a very quick review of what we've looked at so far, though. In the first lesson, we looked at what makes acids acids, and we said that acids were things that dissociated to produce hydrogen ions. And we also looked at these indicators here, didn't we? The litmus, the methyl orange, the phenolphthalein. We compared them with the universal indicator, and we realised that some types of indicators have certain advantages and disadvantages. We then moved on, and we started to look at how concentration was calculated, and you should hopefully by now have had a little bit of a practice at converting centimeters cubed into decimeter cubed, so you can properly work out calculations in the type of question we looked at last lesson. We also looked at the pH scale, which is somewhere down here, and we said the pH scale was a logarithmic scale. So in other words, something that was pH 5 was 10 times more concentrated, or a 10 times a stronger acid than something that was pH 6, and we said something that was pH 4 was 10 times stronger than something that was pH 5, so therefore something at pH 4 is 100 times stronger than something at pH 6. That might seem like I've gone through that quite quickly, but that was thoroughly explained in the last video, so if that doesn't make sense what I've said, you need to click back on the previous video. Today we're going a little bit further. These are our learning objectives. We're going to look a little bit more at neutralization. These are, this is the order that we're going to tackle the objectives. So the first one, why are metal oxides bases? So we're going to have to tackle what that term base means. What happens during neutralization? You might think you might think that an acid and an alkali make something neutral. Done. There's a little bit more to it than that, a lot more to it than that. And then, how can a soluble salt be prepared from an acid and an insoluble base? So again, terminology there like a base, a salt, will be things that are probably fairly new to you, and we'll have to come up with decent explanations and definitions for those. So let's begin with this first one. What are metal oxides? Well, metal oxides are very, very simply metals that have reacted with oxygen. If I take iron and react it with oxygen, I get iron oxide. Magnesium, and I react it with oxygen, I get magnesium oxide. But why do we call them bases? What is a base? Well, forget oxides and bases for a second. Think about the alkalis that we've already talked about, the alkalis that you might use at school. So for example, the sodium hydroxide will be a cracking example. When you see sodium hydroxide in the school lab, it's brought to you by the technician in a bottle. It's a liquid. But if we wind back time a little bit, that technician has had to prepare that in the prep room, and she's had to put a solid into water and dissolve it. All right, so that sodium hydroxide comes as a solid. It's like a powder, and they put it in the liquid and they dissolve it to make that sodium hydroxide solution, to make the alkali. So an alkali is something that's soluble, right? Sodium hydroxide is soluble, and it will react with an acid and neutralize it. But there are other things that will react with acids and neutralize them. Iron oxide, all the oxides we've just mentioned, metal oxides, they will react with acids and they will neutralize them, but they're not soluble. I can't take iron oxide, which is effectively rust, and put it in water and watch it dissolve. It won't dissolve in it, it's insoluble. But it will react with an acid to neutralize it. So some people like to think that a base, let's just call it for now like an insoluble alkali. All right, it's something that's insoluble, but it will neutralize an acid. And we'll use that term and get much more familiar with it as time goes on. So, we should now hopefully know the difference between an alkali and a base, and it's all to do with the solubility. Alkalis end in the term hydroxide, right, OH, and the bases that we're going to learn for now, we'll add another one at the end of this lesson, the bases we're just for now going to say are oxides. So, let's go to that second learning objective. What happens during neutralization? Well, now neutralization for us takes on a bit of a different meaning, because we know that alkalis are not the only thing that's going to neutralize an acid. We know that bases will neutralize an acid as well. So you might be thinking, well, fair enough, it's when an acid neutralization is when an acid and an alkali, or an acid and a base come together and we produce something neutral. But we've got to go a lot further than that. Here we go. So let's start with our typical alkali neutralization. When you sit down for your assessment or next year for your GCSE exams, you're likely to be given a word equation that you won't have prepared for. Okay, and if we're given a word equation for acids and alkalis, it's going to be really helpful for you if you know the rules to how these chemicals behave, so you can predict your own products. If you know the rules, you don't have to learn any equations, right? You know the rules, you use the rules, and you get the marks for it. So, if you look on the board here, we've got a simple equation. Sodium hydroxide, that is our alkali. Yeah, it's not a base, remember, it's the alkali. We're going to add that to an acid, and that tells us it produces something called a salt and water. Now, you shouldn't be surprised about the water, because we know that the acid has the hydrogen ions in it, and we know that the hydroxide has the OH minus in it, and they all come together to make the water. That's where the water comes from. But what about the rest of the stuff from the sodium hydroxide? What about the sodium? And what about the rest of the stuff from the acid? Yeah, they are going to come together also and produce something. And the thing that they produce we call a salt. Now, you've got to be able to name what that salt is. Okay, now remember, we're talking about alkalis here, not bases, but we'll come to bases in a second. You're going to be able to have to predict the name of that salt. Well, the name of that salt is going to depend on two things. It's going to depend on the acid that we use, and it's going to depend on the alkali that we use. I'm using sodium hydroxide here as an example, but we could have used potassium hydroxide, lithium hydroxide, calcium hydroxide, all sorts of hydroxides we could have used. So, here in this example, I am using sulfuric acid. Now, there are three acids we've got to get comfortable with: sulfuric, nitric, and hydrochloric. Right? They are the only three that you'll be given in questions like this: sulfuric, nitric, and hydrochloric. Now, if I use sulfuric acid, if we go and have a look at the salt, we can see that the last name of the salt is sulfate. But the first name of the salt is sodium. The first name of the salt will always be the first name of the alkali. So if I've got sodium hydroxide and I add sulfuric acid, I'm going to get sodium sulfate as my salt. And that'll be a soluble salt. That'll be dissolved in the water that's also produced. But what if I use a different acid? What if I use nitric acid? Well, the first name of the salt is still going to be sodium. That rule doesn't change. But the last name of the salt is going to reflect the acid that's being used, right? So we now get sodium nitrate as the acid that's been used because we've used nitric acid. And if I use hydrochloric acid, which tends to be the hardest one because people want to say that the salt ends in something beginning with a H because hydrochloric begins in a H. But it's actually a chloride we make. Now, I could use any metal, right? Let's just go through another example. I could use lithium hydroxide. So, for example, lithium hydroxide and nitric acid will give me lithium nitrate and water. Calcium hydroxide and sulfuric acid will give me calcium sulfate and water, and so on. But just remember that one down at the bottom, that if it's hydrochloric acid, we get a chloride and the water. Now, you will get some practice on this as time goes on. But just make sure for now that, if you're pausing the video and you're writing down these sort of generic equations, you're writing down the endings that each acid gives, they are going to be really, really important for you. And assessment on that will come, okay? Now, that's with the hydroxide, that's with the alkali. But that learning objective we first looked at started talking about bases, yeah? Metal bases, metal oxides. So what if I used a metal oxide? Well, if I use sodium oxide, you can see not a great deal is changing. In fact, nothing changes at all, apart from the fact it's sodium oxide as opposed to sodium hydroxide. And what that means is, oh, look at that, I have made a huge error on my PowerPoint. I'm going to correct that in real time now for you. Look at that. There we go. So, if we use, sorry about that. Now my printer's going. Can't catch a break, can I? Finally, it stopped. So if we use sodium oxide, all the rest of the rules still apply. Sodium oxide plus sulfuric acid still gives me sodium sulfate and water. Sodium oxide plus nitric acid still gives me sodium nitrate plus water. And sodium oxide plus hydrochloric acid still gives me sodium chloride and water. So it's exactly the same. But in reality, if we were actually doing this as a practical, the sodium oxide would be a solid and we would have to drop that solid into the acid and stir it, right? The sodium hydroxide would be a liquid, and it'd be a case of mixing two liquids together. Now, there is another type of base I can use that wasn't mentioned in those learning objectives, but it is something that you will come across, and that is a carbonate. So remember, a carbonate, because it's a base, is also going to be insoluble. It's going to be a solid that you sprinkle into your acid to do these reactions with. I'm again using sodium as my metal, and if we have a look at the generic equation there, not a great deal is changing. I'm still making a salt, I'm still making water, but I'm also releasing carbon dioxide. And that's because carbon and oxygen are contained in the carbonate, and they get kind of liberated in that reaction, and they wander off together as carbon dioxide. But when I'm looking at predicting the name of the salt, nothing changes. Sodium carbonate and sulfuric acid still gives me sodium sulfate as the salt. Yeah, sodium carbonate and nitric acid still gives me sodium nitrate, and so on and so on. So the general rule for the carbonate is that nothing changes, just remember to add the carbon dioxide. Yeah, nothing else changes, just remember to add the carbon dioxide. So hopefully you can sort of see that you have a number of different word equations that can be presented to you. You could be given sodium hydroxide plus sulfuric acid. You could be given calcium oxide plus nitric acid. You could be given potassium carbonate plus hydrochloric acid, right? They could do these in all sorts of combinations, which is why it's pointless to try and learn each equation separately. Just learn the rules and you'll be absolutely fine, yeah? And you will get practice on these rules. Now, it is also worth discussing, there we go, that there is one other option as well. We can add just the metal to the acid without the oxide, without the carbonate, without the hydroxide. We can just add the pieces of metal. And that will give us this reaction here. We will still produce a salt, and that will be named in exactly the same way. It will be sodium chloride, sodium nitrate, or sodium sulfate, as long as we're using sodium as a metal. But what does change is we are only producing hydrogen. That comes from the acid. There's nothing with that hydrogen to react with to help it make water. So if I just use the metal, the gas that gets given off is hydrogen. So if we go back to the learning objectives, and you're going to have to check the next video, which will be Year 10, Lesson 3, Part 2 for that, because this YouTube account isn't able to make videos that are longer than 15 minutes, and this is about to be. So please check that link. It will have been sent to you.